In this video, let's see the difference between normal distribution and the t-distribution. The red curve in the graphic is the normal distribution. Let's assume that z follows normal distribution. Z is given by x minus mu of x, that means the mean of x, divided by the standard deviation of x. Now, let's see the t-distribution. The ratio here, it looks similar to z. This x bar is the mean of many random variables. You can think that I go to the population and extract many random samples, and then I average to get this x bar. This part here is pretty much equivalent to the z. The difference between z and the t is on the denominator. If I have the standard deviation of the population, we use the z, the normal standard distribution. If you replace the standard deviation of population by the standard error, this s divided by the square root of n, then you have to use the t. In the chart, the t-distribution for degree of freedom 5 is given by this blue curve. See that there is not much difference between the normal distribution and the t-distribution. T-distribution is just the adjustment to the normal distribution for the fact that you don't have the standard deviation of the population. And this adjustment is necessary only for a small sample size. This n-1, n is the number of observations. We call this degree of freedom. See in the chart that the green curve is the t-distribution with a degree of freedom 30. That means we are using 31 observations, and this is already enough to get something that matches with the normal distribution. Therefore, as n increases, the t-distribution converges to the normal distribution. Let's get the intuition of the use of the t-distribution for a small sample size. The tail of the t-distribution is thick. See, compare the blue curve with the red curve. The point is, in a small sample size, you have more outliers, deviations from the mean. That's why both sides of t-distribution, the tails are thick, and you have more observations in the tails, then the peak of t-distribution is shorter than the normal distribution.